Hello everybody. Now we will try to understand about a three-phase full converter. So three-phase full wave converter, controlled converter, that too, that is by using of SCRs. So as you know, this is a bridge full wave converter, three-phase, consisting of 6 thyristors. And when you talk about the pulse number of this kind of a thyristor, of this kind of a converter, the pulse number is 6. It's also called as a 6 pulse converter. Why? Because on the output side you will be having 6 pulses, whereas a half wave three phase converter is called as a 3 pulse converter, that we have already seen. Now also we will see why it is 6 pulse, how you are getting 6 pulses in the output. So you are having 3 legs. First leg is having thyristor T1 and T4, T3 and T6 for the second leg, T5 and T2 for the third leg. So many students get confused about the labeling of the thyristors. This is a standard labeling of thyristor. You cannot place T1, T2, T3 as ever you want. It should be of this order only. So how to remember, sir? You just have to remember by making the pattern. So first is, this is T1, T2, T3, T4, T5 and T6, like this. So this is the regular diagram of a bridge converter, three-phase bridge converter, that you regularly see in all the textbooks or any material. But I just, for the sake of simplicity, to make it more easier to understand the operation, I have converted this, I have redrawn the same diagram in this fashion. You see, here you are having two groups of converters. Let us say this is called as a positive group and this is a negative group of conductors. This is a positive group and this is a negative group of thyristors. What will this positive group will do is, it will conduct only when the voltages are high. Okay, it will conduct only high voltages. And this bottom one, which is a negative group, it will conduct only if the voltages are less, or I can say negative, or in simpler terms, if the voltages are less, then this will conduct. If voltages are high, this will conduct. So the positive group is in which connection? It is in common cathode connection, isn't it? Whereas the negative group is in which connection mode? Common anode connection. So this is a very, very important MCQ. That is, in a three-phase bridge converters, the positive group of converters are connected in which mode? They are connected in common cathode, and the negative group are connected in common anode mode. So sir, what are the common anodes and what are those thyristor labeling? See, this top 3 which are there, the thyristors, are the positive group only. So T1, T3, T5, T1, T3, T5. Okay, again next comes the negative group. So here is T1, again there should be a T2 here. After T2, T4 should come bottom and T6, like this you have to remember. And you see, here is the common cathode. So this common cathode is a positive, or the positive of the load, and the common anode is the negative of the load. And you have to again connect them back in series in this way progressively. Okay, so to this combination of T1 and T4, you are connecting the R phase, and for T3 and T6 you are connecting Y phase, and for T5 and T2 you are connecting the B phase. If you see here also the same thing was happening, isn't it? R is connected to which thyristors? T1 and T4. Y is connected to T3, T6. B is connected to T5 and T2. So this is the same as this diagram only, nothing different. Just the way you draw the circuit is different. In fact, drawing in this way will try to enhance our understanding much better. It will be much easier even for a beginner student who is usually getting confused in power electronics. He will easily understand the operation if he studies through this diagram. And the voltages applied are the per phase voltages, that is VRN, VYN, VBN. VRN is Vm sin omega t, VYN Vm sin omega t minus 120, VBN Vm sin omega t minus 240 degrees. Okay, because it's a three-phase balance system. So here is the supply voltage waveform. Now let us try to plot the output voltage waveform considering alpha is equal to 0 degrees. If you are considering alpha is equal to 0 degrees, means it is equivalent to putting a diode instead of an SCR, because SCR will conduct as soon as it gets forward bias. A diode conducts as soon as it gets forward bias. That is nothing but firing angle is 0 degrees. After it gets forward bias, after some time, if you are triggering that particular converter or the device, then it is said that you are applying some firing angle, triggering pulse. So I am considering now for alpha is equal to 0. Alpha is equal to 0 for, let us say, thyristor T1 will occur when VRN is positive. So these things we have already discussed. So let us start our analysis from alpha is equal to 0 degrees. Alpha is equal to 0 degrees corresponds to omega t is equal to 30 degrees. Okay, at 30 degrees. So I will take this time slot of 30 to 60 degrees. Okay, 30 to 60 degree time slot. We will see what happens. So between 30 to 60 degrees, okay, which voltages, which diodes or which switches will be conducting, we have to analyze. So if you look at the positive group, it is common cathode connection. Common cathode connection, the cathode potential is the constant. It only depends upon the anode potential, which will decide which thyristor will conduct. So which anode potential will be high, that will conduct first, that we know. So after alpha is equal to 0 degrees, you see which voltage is high. If you compare, the R phase voltage is higher to remaining two phases. So R phase is connected to which positive thyristor? T1. So after alpha is equal to 0 degrees, the thyristor T1 will start conducting. Okay, T1 will be conducting. So you are going to get an output current from the source from T1 and it will go to the load, and now coming back, which thyristor in the negative group will conduct. So this is a common anode connection. In common anode connection, which cathode is least will conduct, isn't it? So if you look at after alpha is equal to 0 degrees only, which voltage is the least? B, this is Y phase voltage is the least, isn't it? So Y is connected to which thyristor? 6th thyristor. So through 6th thyristor, it will go back into the supply. Okay, it will go back into the supply. So from 30 to 60 degrees, T1 and T6 are the thyristors which are conducting. Okay, this is a very important thing. T1 and T6 will start conducting from 30 to 60. So I want to find out what is the output voltage when T1 and T6 are conducting. So when T1 and T6 are conducting means, now if you have seen, what are the sources that are actually supplying the load? R phase and Y phase. This is VRN, this is VYN, and here is the output voltage V0. So if you apply KVL on this loop, you're going to get V0 is equal to VRY, isn't it? This is what you're going to get. Or in other words, I can tell what you'll be getting, the KVL is VRN minus VYN, or simply V0 is equal to VRY. That means the output voltage is equal to the line voltage, because line voltage is that voltage which exists between two phases, and two phases are what? Connected to the load, positive and negative of the load, isn't it? Therefore, the line voltage is going to be your output voltage, and we have to find out what is that output voltage at different angles. Let us say at alpha is equal to 0 degrees. At alpha is equal to 0 degrees means omega t is equal to how much? 30 degrees. As you know, V0 is equal to VRN minus VYN. So what is VRN? Vm sin omega t. What is the omega t that I want to find out? At 30 degrees. So Vm sin 30, that will be nothing but Vm by 2, isn't it? Minus Vyn. What is Vyn? Vm sin omega t minus 120. Omega t is how much? 30 degrees. So 30 minus 120 is how much? Minus 90, isn't it? So that will come out to be plus sin 90 is Vm only, 1. So you're going to get V0 is equal to 1.5 times the Vm. So where is the Vm? This maximum voltage is the Vm, and 1.5 times the Vm. That means higher than the maximum voltage of individual phase. Let us say that 1.5 times Vm is somewhere over here. This is that 1.5 times of Vm voltage. That is the voltage at the output at omega t is equal to 30 degrees. Why? Because from 30 to 60, T1 and T6 are the conducting. Now I will see what is the voltage at 60 degrees. Omega t is equal to 60 degrees. So when you are having omega t is equal to 60 degrees, even at 60 degrees, T1 and T6 are only conducting, isn't it? So output voltage will be same, VRN minus VYN. Just put omega t is equal to 60 degrees. So when you are putting omega t is equal to 60 degrees, so Vm sin omega t is 60. So sin 60 is how much? It is root 3 by 2. So output voltage will be root 3 by 2 Vm minus Vyn. So 60 minus 120 is minus 60. That will come out to be minus 1 by 2. That will be Vm by 2. So Vm sin omega t minus 120. Omega t is equal to 60. 60 minus 120 is minus 60. So that finally it becomes plus Vm sin 60, which is nothing but root 3 by 2. So again you are going to get root 3 by 2 Vm only. And finally V0 will be equal to root 3 times Vm. Okay, 1.732 times of maximum voltage. That means it may be something higher like this. Okay, this is root 3 times of Vm. Now let us take the next time slot, that is from 60 to 90. After 60 to 90, let us see which thyristors are still conducting or not conducting. if you see from 60 to 90, still R phase is the highest voltage to the positive group, and still Y phase is the highest voltage to the negative group. That means is the highest negative voltage to the negative group. That means between this time slot also T1 and T6 are the only thyristors which are conducting, okay, from this time slot also. So as long as T1 and T6 are conducting, the output voltage is VRYN, VRN minus VYN. Okay, now I will see what is the voltage at 90 degrees. At 90 degrees, what is the voltage? So simply I will put omega t is equal to 90 degrees. When I will put omega t is equal to 90 degrees, Vm sin 90. What is Vm sin 90 is equal to Vm only. So now V0 will be equal to Vm minus Vyn. That means put omega t is equal to 90 degrees, you will get minus 30. So sin of minus 30 is minus sin 30, that is minus root 3 by 2. That will come out to be plus root 3 by 2 Vm. 90 minus 120 is minus 30. So this will come out to be plus Vm by 2. So then you are going to get V0 is equal to 1.5 times of Vm. So again the cycle has come back here. It became again 1 by 1.5. And again after 90 to 120, okay, after 90 to 120, you see which thyristors will be conducting. T1 will be anyhow conducting because still R is only the highest, but now which is more negative means B is more negative, isn't it? B phase is more negative. That means now positive group T1 is conducting, but in negative group which is connected to B will conduct. So T2 will conduct, okay. Now the cycle has been changed. Now it is T2 from 90 to 120. If T2 and T1 are connected to the load, so what will be the output voltage now? So T1 and T2 are connected to the load. That means R phase to the positive of the load and B phase to the negative of the load, isn't it? So the output voltage will be VRN minus VBN. Now let us see what will be the voltage at, so this is the output voltage VRN minus VBN. So I want to find out what will be the output voltage at 120 degrees, omega t is equal to 120 degrees. So when I am putting omega t is equal to 120 degrees, sine of 120 degrees will be, so sine of 120 degrees will be root 3 by 2. So you will get Vm into root 3 by 2 minus Vbn. So omega t is equal to 120. 120 minus 240 is minus 120. Sine of minus 120 is minus root 3 by 2. This will come out to be plus Vm into root 3 by 2. So this will come out to be finally, you will get Vm times of root 3. Again 1.732. That means you got the maximum phase voltage like this. So if you try to plot the waveform will look something like this. So this is how the output waveform will look like. So this is the output waveform which is looking like this. So when you try to observe this particular cycle over here, can you tell me for how much duration each thyristor is conducting? So let us take T1 only. T1 has started conducting from 30 degrees. So in this slot T1 is there. T1 is there. In this slot also T1 will be there. In the next slot T1 will not be there. So in this slot also T1 will be there. Why? Because in this 120 to 150 degree slot VR is still high. So here you will have T1, but T1 and T2 will be there. And after this 150 to 180 degree slot, Vy will be there instead of T1 in the positive group. That means if you look at one thyristor T1 only, for how much degrees it is conducting in one cycle? 1, 2, 3, 4. 4 times of 30, that is 120 degrees. So I can directly say that conduction angle of each thyristor is 120 degrees. And as I already told you, the pulse number is 6. You see 360 degrees is here. See, count how many pulses are there in the output. 1, 2, 3, 4, 5, 6. Therefore it is a 6 pulse converter. That is output frequency is the 2 times the input frequency. If thyristor conduction angle is 120 degrees, can you tell me what is the average current through the thyristor? So IT average will be equal to I0 times 120 by full cycle is 360 degrees. So 120 by 3. So IT average will be I0 by T and IT RMS will be equal to simply I0 by root 3. So these are the RMS and average currents through the thyristor, each thyristor. And each thyristor is conducting for 120 degrees. And in this cycle, tell me where you are getting maximum output voltage. You are getting maximum output voltage at 60 degrees, isn't it? At 60 degrees you are getting the maximum output voltage, and that maximum output voltage is equal to root 3 times of the Vm. Okay, that is the maximum voltage. Next we will see what will be the output voltage at 90 degrees. And at 90 degrees, what are the thyristors that are conducting? Still T1 and T6 are conducting. So at omega t is equal to 90 degrees, since T1 and T6 are on, output voltage will be same like this only. So sin 90 will be equal to how much? Will be 1. So this will be Vm, Vrn will be Vm, and minus Vyn. So put omega t is equal to 90. So 90 minus 120 will be minus 30. So sin of minus 30 will be equal to minus 1 by 2. So that will come out to be plus Vm by 2, and what you will get is 1.5 times of Vm. So if you look at the voltage at 90 degrees, it will be 1.5 times of Vm, which is less than root 3. Okay. Next, at omega is equal to 120. Okay, omega t is equal to 120. What is happening at omega t is equal to 120? T2 thyristor has been triggered. After T2 thyristor has been triggered, what are the switches are on? That is nothing but T2 and T1. T1 and T2 both are on, isn't it? So when T1 and T2 will be on, that is, the load is connected to R phase on the positive side and T2 is B phase. So the output voltage will be Vrn minus Vn, isn't it? Then if I want to find out what is the output voltage at 120 degrees, at 120 degrees omega t is equal to 120 degrees, Vrn is Vm sin omega t. So sin of 120 degrees will be equal to root 3 by 2 Vm. So minus Vm omega t minus sin omega t minus 240 degrees, that is for Vbn. So put omega t is equal to 120, that will become minus root 3 by 2 Vm, that will come out to be plus root 3 by 2 Vm, then you will get root 3 times of Vm. So the voltage at 120 degrees is again root 3. But there is a twist over here. T2 has been triggered at 120 degrees. Then what if before 120 degrees? Before 120 degrees, okay, before 120 degrees, T1 and T6 only are the conducting, no? Because assuming that the load is continuous, the current will be continuous. So somebody has to take up the current until the next set of thyristor has been triggered. Therefore, before 120 degrees also, T6 will be conducting, but at the instant of triggering 120, all the current in the T6 will be transferred to the T2. That is the logic over here. So when T1 and T6 are conducting, let us take what is omega t is equal to 120 degrees. So when you put 120 degrees here, you will get root 3 by 2 Vm minus 0. So you will get 0.866 times of Vm. So this is going to be the output voltage due to T1 and T6 just before T2 has been triggered at 120 degrees. So 0.866 means somewhere over here. So if you are supposed to draw the waveform will look like this. So if I keep proceeding forward like this, so the output voltage waveform looks something like this. So this is the output voltage when alpha is equal to what? 30 degrees. And this was when alpha is equal to 0 degrees. Now what I will do is, I will further increase the alpha by 30 degrees more. That is, I will make alpha is equal to 60 degrees now. So if I make alpha is equal to 60 degrees, what happens to the triggering pulses? Triggering pulses will again shift by 30 degrees more from this side, isn't it? Now T1 will be triggered at 90 degrees and T2 will trigger at 150 degrees. T3 trigger at 210, so on. So we will continue our discussion on three-phase full converter for different other different firing angles. So when we have seen in the first video, this is when alpha is equal to 0 degrees. That is what we have got the waveform. And if you look at this switching sequence or the sequence of conduction of switches, as you know, the conduction will start from alpha is equal to 0, that is from 30 degrees. So you have to start looking from this side. So your switching your sequence of conduction of switches will be T1 and T6 will conduct in first set, and again you have T1 and T2, and then you have T3 and T2, again T3 and T4, T5 and T6, T5 and T4, and T5 and T6. This was the switching sequence. So if I write the conducting order of switches, then it would look like this. So starting from alpha is equal to 0 degrees, this is where alpha is equal to 0 degrees, isn't it? Because this is 30 degrees, that is where the conduction will start from. So at alpha is equal to 0 degrees, already thyristor T6 has been conducting. So T6 and T1. After T6, T1 has been started to conduct at alpha is equal to 0. So this is one pair. And after that, after this, T1 is already conducting and next T2. So T1 and T2. And again, what will be there? T2 and T3. And then T3 and T4. Again T4 and T5. And then T5 and T6. So this is for the entire one cycle of input. So there was a question asked in AP Transco 2019 regarding this concept of switches conduction. So in the conducting pairs of SCRs in a bridge type 3-phase AC-DC converter with SCRs 135 connected to the top half, that is nothing but the positive group, 462 in the bottom half of the converter and supplying a resistance load R. So they are supplying resistance load and you are supposed to find out what is the conducting pairs. So just look at this particular sequence or the pair that we have derived here. So just compare the options. You see T1 and T2, T2 T3, T3 T4, T4 T5, T5 T6. So here also you see. So option C is the right answer. Even option A is the right answer for this question because T6 T1, T1 T2, T2 T3, like this it started. So S6 S1, S1 S2, S2 S3, S3 S4, S4 S5, S5 S6, like this. Or if you take the order from this side, the same cycle will repeat like this. Again from S1 S2, S3 S4, again S4 S5, S5 S6, like this, so on it will go on. So both option A and C were the right answer for this question. And even in the key, it was final key also it was declared A and C both are the right answer. Now what we will do is we will try to further increase the firing angle by 30 degrees. So let us say I am making alpha is equal to how much? 30 degrees. Now I am making alpha as 30 degrees. So when I am making alpha as 30 degrees, where will the triggering pulse be applied? Triggering pulses will be applied at, if this is 30 degrees, okay, this is alpha is equal to 0 point and alpha is equal to 30 degrees means at omega t is equal to 60, okay. So here is where we have to give the triggering pulse to the SCRs. So at 60 degrees, thyristor 1 will be triggered and thyristor 6 will be triggered. And again 120 degrees later, that is at 180 degrees, next set of thyristors will be triggered. That is again 60 degrees later, the next thyristor, that is T2, will be triggered. And here is T3 triggered. That means after 30 degrees later, that means next 60 degrees afterwards, T3 will be triggered. So like this triggering pulses will be applied. So at 60 degrees T1 is triggered. If T1 is triggered at 60 degrees, let us see which thyristors will be conducting. As you already know, Vrn is equal to Vm sin omega t, Vyn is equal to Vm sin omega t minus 120, Vbn is equal to Vm sin omega t minus 240 degrees. Now at omega t is equal to 60 degrees, that is where T1 has been triggered, what are the set of switches that we are conducting? That we have to see, and we will find out the voltage at each time period. So you can see T1 and T6 will be on from the given waveform. If you can see, if T1 and T6 are on means the voltage, output voltage will be Vrn minus Vyn. Why? Because the positive of the voltage, positive of the load has been connected to the R phase and negative will be connected to the Y phase. So at omega is equal to 60 degrees, the output voltage will be equal to Vrn is Vm sin omega t. So Vm sin 60 will be Vm into root 3 by 2 minus of Vyn. So Vyn is Vm sin omega t minus 120. Put omega t is equal to 60, then you will get minus 60. So Vm sin minus 60 will be how much? That will be minus root 3 by 2. So you will have plus Vm into root 3 by 2. This will come out to be Vm times root 3 or root 3 times Vm. So the output voltage at 60 degrees where alpha is 30 degrees will be root 3 times of Vm. That will be here. So this is root 3 times of Vm.